There we go.
Okay. Hey everyone. My name is Shane Mill. I'm from the National Weather Service. Steve Olson unfortunately couldn't be here today, but yeah, let me get right into it. So the National Weather Service's implementation of the OGC EDR API. I'm going to give a quick OGC background, and then talk a little bit about the backend that uses ZAR and X-ray and DAS, everything that we all know and love here. So just a quick background with the OGC from the perspective of the National Weather Service. The NWS began a partnership with the UK Met Office several years ago. The 2020 OGC set up the Environmental Data Retrieval API Standard Working Group. And the OGC really, they're starting to come out with not only the EDR API, but many other APIs as well. They're supposed to work together as building blocks that, you can have one API as a data source, have a process API interact with that data, and so on. So it's a really cool new approach to how we interact with data, and having a standard set aside for that as well. So they've been encouraging sprints, working groups, and obviously the use of GitHub and so on. Global Met Services have a growing interest and backing. The US leads include NASA, USGS, and Unidata, as Rich had mentioned. And one of the goals, especially from Steve's perspective, is to help the WMO realize the goal of data sharing to a broader community, and with 2.0 technical specification. So that's the weather information system for WMO, or WMO information system. Here are some relevant links. I'll share these slides out. I don't want to get too bogged down with the OGC related stuff, but if you want more, more details here, those are the links. We have a blog about the EDR API, the actual website, the standard working group, GitHub, and the deployments page. So excuse this diagram. It's a lot going on here, but one of the National Weather Service's struggles with data in general, and I know this is a struggle pretty much with everyone, is the siloed approach where you have a system devoted to a type of data, and you're really putting a big burden on the user to deal with that. So we have these disparate data formats and systems. What the EDR API, one of the big goals up front, was, okay, how can we homogenize all of these disparate systems and sources into a way to deal with all that data? And one thing that stood out to me with X-ray in particular is the ability to read in data from pretty much all over the place and have one consistent data structure for disseminating that data out. So the EDR API basically acts on top of that paradigm, and provides an abstraction layer from these old legacy disparate systems and sources, and basically gives the user self-describing URLs, standardized and structured URLs. We have schema support for different formats, CRSs, interpolations, etc. The means to the end here, though, is basically giving a feature extraction from a sample coverage. So what I mean by that is basically give the user what they need. If they want a point time series, give them that. Give them an area, a cube, like whatever. Just give them the specific data they want. Don't give them all these netcf files and tell them to go figure it out. That's obviously what we're trying to move away from. So we're all familiar with X-ray, DASC, and ZAR. I'm just going to keep moving forward here. I basically have a couple of diagrams to explain some of the different approaches here. And these are all like DASC, ZAR, X-ray examples. So one example here is we were looking at GFS model data that comes in GRIB from a Nomad service that NOAA hosts. So we have all these GRIB files for different forecast times. The approach here is to basically combine that into one X-ray data set. Here, this is what could be pretty negotiable. So we chose to group our weather parameters by common dimensions, because that's how we want our users to get the data. And in this specific situation, we have a one-to-one correlation with an EDR API collection name and a ZAR data store. So this is just one example. Another example could be, we have this use case for the national blend of models. In that use case, we knew our users wanted access to all the data at once, but in one collection all at once. So basically, this would be one ZAR data store. This is different from the GFS use case I just talked about, where we're separating by like isobaric levels, depth below, mean sea level pressure, and so on. So basically just highlighting the point that, with X-ray and XAR, you give full flexibility to the data provider to organize the data how they want to. You're not forced to how the legacy data was organized. A basic example, here's the EDR API container out there. Here's a user accessing URL links. They want a feature extraction from a sample coverage, so they select the collection, they select their geometry type. The EDR API uses the X-ray dataset object from reading in from the pre-processed XAR data store, reading that in as X-ray dataset object, and then the Python logic basically parses the data, gets the chunks that they want, and sends it out to the user. Getting a little bit more detailed here, Rich and I recently have been working on an EDR API backend that connects directly to a S3 bucket where he's hosting XAR data. So this is a very simple approach. Here are the EDR API requests. So we have a position and area. Area has not been developed yet, but I'll show position soon here. Where the request comes in, it goes to this basically Flask module that has GUnicorn in front of it. This API .py script handles the query parameters and sends it to the appropriate provider Python module, which is using XAR, Dask, and X-ray to basically read the S3 bucket, the specific chunks that are needed, and sends it out to the user as a sampled coverage, again, with the output format that they want. So in this example, I'll show a netcf and coverage JSON example. So let me get into the fun stuff, the demo. So I'm going to start first with just a couple examples with the GFS of sampling geometry types, and then I'm going to jump into the national water model to show Dask in action. So first of all, let me take a step back. Here's the EDR API homepage. There's a JSON representation too if you chose to traverse it through link relations, but it also has a user interface. One thing that we thought was pretty important here, though, is to give the users the ability to like search for data. So I know our GFS collections, one of them has tags associated with them with temperature as a weather parameter and isobaric levels. So I'm going to click submit. Here's the search response. It's really ugly, I know, but it takes us right to the point of making a data query. So if I make this giant, we have a position, an area, a cube, a trajectory, and a corridor. So I'm just going to do a position and area today, unless people want to see more, but it'll get the job done. So if I click on position, here we end up with a user interface to help a user make a query. So if I zoom in a little bit to like Washington, D.C., I'm going to select temperature for a time range for multiple isobaric levels as well. And click show data. And here, I don't know what happened to the user interface, but you end up with a point time series. What this is doing here really is just displaying the coverage JSON, which was the output format here. So if I open a new tab, I just copy that in there. This is basically using the XAR backend to give you a coverage JSON response for a time series for multiple levels for a point. Coverage JSON contains metadata as well, which is useful to application developers. And then here's all the data. So I'm gonna move forward pretty quickly here. Let's get into area really quick. Similar user experience here. You can select a big area on the map here. Excuse my select being open. Click temperature, again for a time series for multiple Z levels. And click show data. So again, this is reading coverage JSON, and it's going to display it on this map. We've added some user interactions here where you can visualize the data. Here's a color palette attached to it. We've added an opacity slider as well. And we have different output formats. So the great thing about X-ray having that common data structure that you can interact with, I could create plugins that create the coverage JSON. They supply a GRIB output here as well, so it downloads to the browser, netcdf. And that cog takes a little bit of time, so I'm going to skip cog. But again, just having this user interaction here, which is pretty consistent, along with a simple and structured URL here as well, helps a user create an API request, and you're good to go. So now I definitely want to demo the Dask stuff. So let me get into the national water model reanalysis. So I'm going to start with a relatively simple request. So here I'm going to select somewhere along like the Potomac River here. And this point request will find the nearest feature, basically the nearest rain gauge. The what you need to know about this backend data, it's hourly data that goes all the way back to like 1993. So it's an extreme amount of data, and this will allow a user basically to subset the data by, in this case, what I'm about to show, a relatively small time series. So this right here is basically less than a day, like 6 hours. I'll click get data, and I have this open here. So you can see like the Dask like dashboard in action here. I'm sure everyone's familiar with this. So currently it's reading the S3 bucket. It's getting the data that it needs, and it's going to output coverage JSON. So we need to give it just a second to move through this. Okay, so it should be right over here. So here you can see the time series here. Okay, so a relatively small time series, that's great. We're demonstrating the fact that, hey, we have all this data that goes back to 1993. It's hourly data, and we effectively have subsetted it to a point that a user can need. We can also add the ability to do a multi-point selection or an area selection containing all of the gauges within that area. A really cool thing that Rich and I have been talking a lot about is, okay, what if we know a user wants data for one point for the entire time series? Like, that's a lot to ask for, but not with like the Pangeo idea of backends and Dask and chunking. Like, this is now possible. So I have right here a saved query. I have it using localhost because I found out my proxy has a timeout on it. So what I'm going to do here is delete basically the date time selection. So I just want to point out like the URL structure. We have the collections endpoint with a collection name. The latest instant, it's a position query. The chords come in well-known text representation. We have a parameter name, which is streamflow. Ignore the CRS for right now. And we're doing an output format in netcdf. So let me go ahead and fire off this request. So now I want to open up the Dask dashboard here, and we'll see everything in action. So basically it's taking a look at the S3 bucket. It's now reading the necessary data in. Since everyone's experts here, I basically have a local cluster with only 4 workers right now. So obviously we could scale that out quite a bit. If I go back to the status, we could see how things are going. Bear with me for a little bit here. So this is, I believe, just a reading in of data. Reading in of the specific chunks from the backend S3 bucket. And what's happening here is the EDR API provider is reading that S3 bucket. It wants to read it in as an X-ray dataset object. We're pointing directly to this specific feature ID. So what the EDR API is doing is taking the latitude and longitude. It's basically finding the nearest neighbor to a specific gauge or a specific feature ID. So one of the next steps here for sure is, okay, what if you know your feature ID, you know your gauge? We want the ability to be able to query that as well. So at this point, the data has been read in, and now we're creating the netcdf output. So I basically, very simply, I'm using the X-ray to netcdf function to do this, and it's doing this in parallel as well. So one thing I'll have to figure out though is, okay, for a request that takes longer than what a web service could provide, like without a timeout or something like that, how we could add to the EDR API some type of, here's a link to your feature data, or like some type of pub sub mechanism or something along those lines, where a request could take longer than a couple minutes. We certainly are looking at adding that into the mix as well. So we should be nearing the end of the processing of this data. And what you'll see is netcdf will download to the browser here. So if you're a developer, you could take a URL request, run a curl command, and get the data as well, obviously. So here we've had the NetCF now is downloading to the browser with exactly the data that the user requested. We don't have to give them too much. So what Rich was able to do for me is take this, basically this NetCF file, and he has it loaded into a Jupyter notebook here. So here's like the example EDR NetCF file. You can see the X-ray data set here with the full time series. He's using HVplot to plot the data, and you can see the full time series laid out here. So with that, let me just summarize very quickly, and then I'll stop talking and open up for questions. So key takeaways, the National Wire Service EDR API uses similar, if not the same. I'm going to go with the same technologies that the Pangeo community uses. The EDR API implementation is an implementation of an international standard. So one thing to keep in mind here, if you're looking for an API to disseminate a backend that you're using, you could have an implementation similar to this that's backed by an international standard community. For those interested in implementing the EDR API, the Pangeo API implementation is a great starting point. We forked it from there, and we have since diverged, but I'm trying to get back to being right with the Pangeo API master. In addition, the EDR API Standard Working Group, we're definitely looking at a best practices document to really help developers out in making their own implementation. And I definitely look forward to becoming more engaged and involved in the Pangeo community. A while back, I definitely, Ryan and I and Steve had talked a while back, but it's good to be more engaged now that I've been talking to Rich too. So I just want to thank everyone for their time and open up for questions or comments.